And so I got to play around with a lot of cool code there. That's when I first got interested in scraping. At PyCon 2010, I took a tutorial very similar to this from Mr. Ashish Leroy. I'm hopeful that many of you know him. He's part of the foundation of the Boston Python Conference that teaches people in Boston, the Boston Python group that teaches people in Boston about learning Python. I myself am one of the core founders of PyLadies when it initially formed 2 years ago. And I've put on numerous web scraping tutorials within the greater Los Angeles area, usually affiliated with PyLadies, but sometimes with other open source library conferences. I am KJam on Twitter and Freenode if you want to reach me, or on GitHub. So again, as I said, depending on how far you got with your installation, if you need my help later, I always idle on Freenode, and I'm always available via Twitter, and probably a lot of you have my Gmail from sending out these things, so feel free to reach out to me. Hopefully we get the adapter soon here, or maybe we can call Stuart over. Okay. Yeah, I'm looking for the like small map. Yeah. Yeah. I'm literally only waiting for an adapter. Oh, thank you. Yes. You are my hero. Already you have an A+. Yeah, well, we'll start low. We'll get there. Awesome. Thank you. Do I need to turn this on? Is it on? Okay, super.
And the resolution has to be 1024.
Okay, let me just find my displays. It is awaiting launch. All right. What is the resolution I should try and set it at? Oh, well, good times. All right. Well, I'm going to deal with some resolution fun, but we should get going. All right. Okay. Okay. So let me move my... All right. I will try to, during our first break, get us some better resolution because this is going to be fun. All right, that's not going to work. All right. Okay, So apologies for the resolution issues. Hopefully we'll get those settled. All right, so why scrape the web? Obviously, the web is a vast source of information. There's many things that you can find on the web that you cannot find elsewhere. Wow, really? You can automate simple or complex tasks. So let's say that you have a task that you run every day or once a week. You go and you download a document and you utilize information from that document to do things. Scraping the web can help automate those tasks. Sometimes you want to keep up with news with friends and family. You don't want to have to check numerous websites, or say you're traveling and you're not going to have a data plan, or whatever it might be. You can allow scripts to automate those things for you. It is super fun to scrape the web and really liberating, I would say. You can learn more Python. So if you're new to Python, scraping the web is a great way to be able to interact with Python and learn new things about Python while also doing something that's probably a little bit more interesting than playing with strings. A little disclaimer that I like to say when I teach these types of things, if you plan to utilize the content that you scrape, just please be aware of copyright, fair use, those types of things. It's important to know about it so that hopefully you can avoid any sort of legal or even just interpersonal issues. If you plan to defy copyright, just don't point people back at me as the source of your copyright violations. And it's really, really easy if you're scraping to find the original author, creator, or photographer of your work. It's usually located on the page somewhere easy to find. A lot of times people are a lot less perturbed or angered if they find that you're sourcing them. You're linking back to their page, or you're linking back to their bio somewhere, or you're at least giving their name credit. These photos are from so-and-so, right? And whether you choose to, distribute the scraped content in any which way, you should at least inform yourself briefly of media law. I took a media law course when I got my master's in journalism, so I know a little bit of that, but at least read through the FAQs on fair use, because a lot of times how you want to use it, even if you're disseminating it in a particularly lengthy way, is usually covered depending on your intentions by fair use. My one final disclaimer is not to be evil. It's fairly easy to use these libraries and certain other libraries that I will reference or talk about to become a spam bot or to spam people. Please don't do that, because everybody hates spam. And just always use your best judgment when you're determining, what to use your scraper for. And if you feel like you're kind of on the borderline of something that may or may not should be exposed, then maybe err on the side of caution and err on the side of doing what you would want somebody to do with your content. Would it be yours, right? Okay, so we're gonna dive right in really quickly. We're going to get a web page. So as you can see, I'm using just urllib2. This is part of the standard lib. And if I were to get this in my, let's see how easy this is gonna be. In my, terminal. Okay, so here I am. Apologies. Let me see if I can get this behaving properly. Nope. Okay. No. Okay. So let me. Okay, I'm in IPython. As I mentioned today on the class board, IPython is my preferred Python shell. This is because IPython, similar to IPython Notebook or whatever it's called now, has quite a lot of helpers. So it has a lot of cool syntactic sugar, so to speak, to allow you to run and investigate different objects within your Python shell that a bare Python shell wouldn't have. You can do the same thing. So I'm going to import urllib2. Which there's now a urllib3 with even more fun things and Python 3 support. With urllib2, I am going to Okay, first I'm just going to open this, right? So I'm using urllib2, URL open. I'm opening google.com. Let's see what I came up with. All right, source. So source looks like what? What is this? A socket, right? It's a socket, right? This is very similar to opening a file, right? If I source.read, what do you think is going to happen? It's going to read maybe a line, right? Let's see. Holy Lord. All right, what did it do? It pulled the entire HTML response. What is source.read going to do now? What am I getting now when I further read? End of line, right. It has already opened. Okay, so whoopsies. Bad job, KJam. Let's go back and get our source. Yeah, let me see. Is this going to work? Yeah. Okay, so let me go back and do this, right? So now I have my source again, right? Okay, so I'm going back to urllib. I'm saying go open this website, right? Go ask for HTTP response here. Now, if I would like my HTML somewhere, now I have my HTML, right? And this is the entire HTML of google.com as one string, right? So let's take a look. I want you guys to answer some questions for me. And if I could get my mouse operating properly, then I can ask you them. Okay, so whenever you use a new library, I want you to pay attention to the documentation. Obviously, there's great documentation for the standard lib on python.org. They have examples out the wazoo, really anything that you could ever want to know about urllib2 or urllib or urllib3. So whenever I explore new libraries, I like to open IPython, like I said. The really nice thing about IPython is I can inquire with like a question mark, and it will tell me any documentation that the library has, right? Which I find incredibly useful. So a quick pop quiz. I want you to tell me the answer to these questions using just urllib, right? So we can remember a couple things. urllib2 is going to open up URLs for us. It is then going to, with a .read, return us a string. We can save that string in a variable, right? Then we have a string with all of the site HTML. I want you to utilize your knowledge of Python with that knowledge to tell me, is the word Python on the PyLadies homepage? Does google.com have an image? And what are the first 10 characters on python.org? A bonus, if you finish these 3 tasks, is to find your name on a web page. I want you to get started now. I'm going to give you a couple minutes, and then I'm going to ask for answers. So whether you use IPython or not, you can use a normal Python shell for this. And urllib is part of the standard lib, so you shouldn't have any problems. If you're stumped, talk to your neighbors. Communication is good. Feel free to chat. It's not cheating, it's collaborative learning. Okay, so answer to the first question. Does PyLadies.com contain the word Python? Ah, not all in lowercase. What? How does it have it? Was anybody able to find it? It's capitalized. Did you guys use your browsers? Don't cheat. Terminals only. All right, so I have my PyLadies source here. And I can do a simple, right? Or, so, as most PyLadies, they are very proper. They use Python with a capital P, right? Okay, does Google have an image tag? Yes, okay. How did you find it? You said yes, yeah? How did you find it?
I searched for open angle bracket ing space in the source.
Okay, perfect. And you found it. It was there. Okay, and tell me about what are the first 10 characters on python.org? Doc type, yay, we have properly formatted HTML, HTML5 compatible, always exciting. As you scrape more of the web, you'll get more and more excited when people follow simple rules. It's not that hard, okay? Luckily, python.org, of course, we're Python people, we follow the rules. So let's get a little bit more complex. Obviously, urllib, urllib2, and urllib3 are a great way for really simple requests. But they don't really tell us anything about the website. Having a large string of HTML is not really very useful, as you can see. Testing contents is not that exciting. And I'm sure, hopefully, some of you are also familiar with the requests library that Kenneth Reitz put together, which is essentially a wrapper around these libraries. But, you know, it's powerful for what it does. It is not really powerful beyond that. It's a far cry from a true web scraper, right? So you want to parse data the way that your eyes parse data, right? When you go to a web page, you notice the designs that they have chosen, right? You notice the navigation across the top or the navigation down the side. You notice content because it's bold or in a table or arranged in some way. And so you need a more complex library, right? So today we're going to cover BeautifulSoup, LXML, which are two very powerful parsers. We're going to talk pretty in depth about XPath, which is a really powerful way that you can use XPath syntax with numerous libraries. It's supported by numerous libraries. We're going to, in particular, use it with LXML. And we're going to go into Selenium, which is a browser-based web scraper. But first, let's talk about what's in a web page, okay? So here, HTML and CSS are going to be your friends. JavaScript is kind of a sort of sometimes friend. But HTML and CSS are definitely your friends when it comes to web scraping. If you don't really know much about markup, either HTML or XML, you're going to learn a lot about it, and don't be afraid of it. And if you don't really know much about CSS, you'll come to learn it as well. If you're from the front-end development world, web scraping is going to be muy simple, okay? So, Developer tool and Firebug, or however you like to interact with the pages when you start to inspect elements and dive more into depth into the responses that you're getting from the websites, they're your weapons, right? They're going to help single out how is this piece of content unique? How can I always access this piece of content? Even if the page may change, they might change the color, they put a funny April Fool's joke up, how might I better parse to get exactly, accurately, and explicitly the data that I would like to get from this page? And so we're going to investigate a favorite page of mine. I am from Los Angeles. I have lived there for numerous years. So we're going to go to downtownla.com. You're going to click on play, and then you're going to click on happy hours. So feel free to do that. I'm going to pull it up right here. Okay, so here are my list of all of my happy hours in downtown Los Angeles, which is where I, until recently, lived. And what I can do, as you can see, I primarily use Chromium in Ubuntu for my web browsing, but it is very similar to Chrome. And what it does, similarly also to Firebug and everything else, is I'm going to be able to click on this, right-click, highlight, inspect element, and I'm going to see something like this, right? And as you can see, it's starting to dive into the page. And in this page, I'm noticing a couple of things. A great thing that Chrome does that I believe Firebug does on the top of the panel, and I think IE Developer Tools does in a very similar way, is across the bottom is going to give me a bit of a nesting of the different HTML tags that it is going into as I inspect that element. This is going to be key later, and it's definitely going to be something that you're going to constantly go back to and reference. Well, what's the parent element of that, and what's the parent element of that? And you can see in my tools, it goes all the way back to HTML, which we know is the root of the document, right? Then I'm going into the body, the center, and what I'm noticing is there's quite a lot of table action going on here. This HTML, as we can see, is kind of old school. It's very table formatted. But this is powerful now that we know. So we can see that the text that I'm interested in is right here. It's this box. And this box is inside a table that's inside another table, right? And within that table, I don't know if you can read, but it has a table row and a table column. And in one of these table columns, it has a bunch of paragraphs, all in the table column. So it's in a table inside a table, and then a bunch of P tags. And in that P tag, it's going to have the title for me. It's going to have, it looks like the address. It's going to have the time of day and a bit of a description about what the deal is or what the happy hour is about. So I'm noticing that there is a paragraph with a class here. I have a paragraph, that has a class calendar_event title. Okay, that's useful. This is CSS again. The class is telling me the CSS. And then it looks like most of the information is in other paragraphs just below the title, right? So these are all just other paragraphs. They don't necessarily always have a class. So I know that they're just paragraphs related to that. So how can I use this information to tell me more? Let's talk about BeautifulSoup. BeautifulSoup is one of the first Python libraries used for scraping. It's been around for quite some time. It has been ported now to be Python 3 compatible. This is pretty exciting. I'm still very much a Python 2.7 person because I still am working with a lot of web apps that are built in 2.7, but it's exciting that it will port with Python 3. For a long time, we thought that BeautifulSoup might be destined to die because there was nobody active on the project, but people have picked it up, and that's really exciting. They've allowed for a couple of new functions to be added within the past year, and they have ported it to Python 3, which is really exciting stuff. BeautifulSoup is very powerful. It is also very simple, and it has very few requirements. Sadly, I have been chatting with some of you about LXML and its dependencies. LXML is a bit of a beast. It's intensely powerful and it's very useful, and I highly recommend that if you want to become an expert scraper, that you also learn LXML and you utilize an environment that allows you to set it up. But as you saw, it has a ton of dependencies. It requires a bunch of SLT drivers and other things that a lot of computers don't come with originally. Whereas BeautifulSoup, the dependency is truly regex. And pretty much regex, every computer is going to support that, and it comes with a standard lib. So it's really, really easy to install. I think they have a couple other dependencies now, but it's really easy to use, and if you're working with other people that have a variety of operating systems and a variety of parsing needs, it's always going to be there for you. So let's talk about BeautifulSoup. Let's look at some introductory BeautifulSoup functions, all right? Methods, I should say. So once you create a BeautifulSoup tree object, so to speak, you can run something like tree.findAllA. What is that going to do? Find all the anchor tags, right? And it's going to return it in a list form. So I can then iterate over this, and I can iterate over every link on that page. If I find title, what is it going to tell me? Anyone? Yeah, so it's going to find the first title tag and return that to me. Is it going to return all of the title tags? No, it's just going to return the first, and it's going to return that as an HTML element, which is a particular class type within BeautifulSoup. If I type get href, what is it going to do? It will find the href attribute of an element. So let's say I'm finding all A, and I'm iterating through. How can I get all the hrefs of those anchor tags? Could do something really simple. For A in findAllA, next line, print a.gethref, right? If it doesn't have that attribute, what do you think it's going to return for me? A none, right? So this is a great way that you can start to get at these attributes. If I didn't want an href and I wanted a different attribute, I wanted to get the class attribute, I could just get class, right? And these are methods of the HTML elements, right? Okay, and another attribute of the HTML element is .text. .text is going to retrieve any text within that HTML tag. And this we can start to see is really powerful, because as you start to parse through things, you're not going to want to spit out and save a bunch of HTML, right? You don't want in your database or in your content or whatever a bunch of P tags and B tags and everything else, right? You'd rather just get the text or the content that you're trying to get at, okay? So let's take a look. This is a bit of the content. If you look in the repository, if you've downloaded it, you can look at the BS_scraper, the BeautifulSoup scraper, and you could start to see some of these things. But I highly encourage you to just also type this into your shell. So what I'm going to do is I'm going to do that along with you. So I'm going to first, from BS4, import BeautifulSoup. Now I have BeautifulSoup. If you did not download BeautifulSoup 4 and you just have normal BeautifulSoup, if for some reason BS4 throws an import error, then you can just import BeautifulSoup. You probably have BeautifulSoup 3, which is fine. So what I'm going to do, I still have probably one of my sources lying around here. Oh, that one's probably all. So I have my, let me go get my, let's do, so I'm going to go get the python.org source, and then what I'm going to do is I'm going to push that into a tree. I usually name my core trees, because that's kind of in a lot of the documentation. So if you're ever using documentation, it's really easy. So I'm going to push that into a tree. Oops, sorry. All right, now I have my tree. Wow, what did that just do? I just typed tree, and it printed it. Does it look the same way it did when I was using urllib? No, what do we notice about the way that it's printing the page? It's formatting it, right? It's starting to recognize HTML and the way that HTML is formatted, right? Using my IPython, if I inquire what is tree, then it's going to give me some documentation on what it is, right? It seems to have a length of 7. Here's a little snippet of it. And then it's going to go into some of the BeautifulSoup documentation, right? So what did I say? What were some of the BeautifulSoup functions we talked about? Really? Okay, so what if I wanted to find, how would I find all p tags? Okay, and we're starting to see. Sorry, I'm really sorry about my resolution. Okay, so I'm noticing there's 23 paragraphs, right? It is just pass it into BeautifulSoup. And source is a urllib2 read into it. So that is my tree, and my source, as you can see, is my urllib2 URL open. I'm opening python.org, and I'm reading, right? You could do this as 2 steps if you want to keep your source and your source in some sort of variable, right? Or if you, would rather keep your socket in a variable and then your source in another variable. But this is a really easy 2-step to just open anything. If you're interested in another website, feel free to enter another website here. Oh, so my IPython has tab autocomplete. I think it comes normally with IPython if you use it, but it does kind of depend on your settings that you have. I find it tremendously useful because I can do something like tree dot and do a tab, and it's going to start to give me a lot of different things I can play around with. Okay, so let me go back to this quickly. Okay, so as you can see here, I'm just creating my tree, and then I'm going to, this is the full listing of all of the happy hours, right? And this is, again, all based and further documented in the repository for this course that hopefully you all downloaded in the BS scraper if you want to follow along. Then what I'm doing later in the scraper is I'm creating an empty list, right? This is going to hold my found happy hours, right? Then I am for T in tree find all, p tag, and here you can see I am passing a dictionary with a key of class and a value of calendar event title. What might this be doing? Find all p did what? So what it's doing is it's finding all the paragraphs, right, which I just did. But you know what? When I was inspecting the page and I was looking at the paragraphs I was interested in, the first paragraph always had calendar event title, right? There's probably a whole bunch of other paragraphs on that page that I don't care about. Honestly, I couldn't care less about the navigation of this site. I just want to know the events, right? So what I am doing and what BeautifulSoup allows you to do is to pass a dictionary along with whatever tag you're interested in, and you can pass CSS variables. So again, the class is an attribute of that p tag. When I'm writing the HTML, I'm literally typing p class equals calendar event title in quotations, right? So what I'm telling BeautifulSoup is, hey, go find me all the paragraph tags, but you know what? Throw out all the ones that don't meet this definition, whose classes are not calendar event title. And that will turn up much fewer. The original one turned up something like 27, right? P tags. I believe, well, with the event all, this turns up 150 or something, but that's with all the pagination, right? But this is only going to give me the text that I want, right? I only care about these paragraphs. Then I'm saying text equals t.text. What did .text do again? Can somebody remind me? It gets the text content of that tag, right? So it's pulling that title, right? And then I'm doing something a little funky here, and we're going to go into it pretty in depth. So don't worry if you lose me right now. We will be coming back around. For S in t.findNext siblings, and then I'm appending to the text. Then, after I'm done with that for loop, I am appending to the found happy hours. And then I'm going to iterate through all of the events. If you run this script, it should run within your virtual environment. It will fail upon trying to email me so that I don't get 700 emails today. But what you'll find is, and if you look through the code, is it's going through. I made an array of some things that I like. I believe I put in, I like burgers, I like barbecue, I put in sushi, and it's going to see if that's in any of the descriptions. If it is in any of the descriptions, it's going to email me and say, hey, Katharine, I found these happy hours for you that you might be interested in, and send me a list of all of the happy hours I might be curious about, right? And so you see how this then becomes very powerful and something that I don't have to look at every day, and I don't have to go to this page really ever. I could just have this running on a cron, on a server somewhere, and every day I would just get a new email in my inbox, or say I only cared about it on Thursdays. Great. Well, it's there for me on Thursday, right? But let's talk a little bit about, do we feel a little bit clear on the find all? Are we feeling good about that? All right, we're going to go into find next siblings. Okay, so let's talk a little bit about family trees. There's siblings, there's children, there's parents, there's ancestors, there's descendants. And I'm just curious, what makes HTML a family? Does anybody know why we have family relationships in HTML? Who here, has anybody here dealt with a lot of, has anybody ever had to handwrite an HTML page? Okay, what did you have to put at the top? HTML. What did you have to put at the second top? A head, right? And then what's the rest of the document? The body, right? So we can start to see, okay, an HTML has two kids, right? It has a head and a body. How many kids does a head have? It has a title. Sometimes it has a couple styles in there, right? Sometimes it's got some other JavaScripts, right? Okay, in the body, what does it have? What are children of the body? A table, anything. It could be divs, it could be Wild West of paragraphs. You don't know, right? But we can start to see within a div, what might I have within a div? What might be children of that first div? Give me an example. Maybe there's a span in there. Maybe there's another div. Maybe there's a table. Maybe there's an ordered list. Maybe there's an unordered list, right? And we can start to see how all of these nodes within XML and HTML have all of these family relationships. And depending on where you're at in the tree, you might have siblings, right? Those are people within that same parent node. You might have parents. You might have grandparents and great-grandparents. You might have children, grandchildren, great-grandchildren, second cousins, right? So it's really powerful to start thinking about it this way, because with a lot of the libraries, there's quite a lot of tools around these type of family trees. And as HTML gets more and more standardized and structured, these become even more powerful, right? Because you can depend on sites to be formatted in a proper way that parsing children, descendants, parents will give you accurate and detailed information. It's also a really fun way to just explore a page and see if you can find information that might not be readily available via something more convenient like CSS. So we're going to take a look at some BeautifulSoup family functions. Find children is going to find all children of this element in a list form. Okay, this is again things that we can call on a tag. Find child is going to find just the first child of an element. I will publish all of these slides as well, by the way. So they'll be on my Twitter later today, and I'll also email the group, so you don't have to worry about writing everything down. Find parent or find parents. So find parent is going to find just the first parent of this element. Find previous sibling. This is where it starts to get kind of interesting. This is going to find the closest previous sibling, but only one. There's also a find previous siblings. So if you've located an element and you're interested in the other things within that node, you can utilize this. Yes? Yes. So it starts to go into the ancestor relationships. This BeautifulSoup is not written in the same way that LXML is, has a little bit more about ancestors and descendants. BeautifulSoup, pretty much everything is a sibling, parent, or child. But that's a good question. And then find next siblings. So this is going to be all of your next siblings. So in my example before, what was I doing? Somebody describe it to me. What was I doing here? Describe it to me in, like, I don't know anything about scraping terms. Perfect, right? And remember when I started looking at the source of that page, I was in a row, in a column, and I knew how to find the title, and you know what? The rest of the paragraphs in there were gobbledygook. Honestly, some of them had classes, some of them didn't. Some of them, had other attributes I could use, like IDs or other things. Others of them didn't. So really, utilizing BeautifulSoup, this was the only way that I could accurately find that information. So this is how we start to see that depending on how a web page is built, you might have myriad tools. You might have a small set of tools that you can use. And it's kind of fun to play around and find which ones are the best for the job. Yes? Indeed, it does. So what is T here? Perfect. It's my and we would describe it almost as my current HTML element, right? So as I loop through, I am on a new element, which means in terms of thinking about on the page, I'm here at the top, I'm on the second one, I'm on the third one, and then within that, they're all located within different table rows, right? So that's how I can have the hierarchy of just accessing this table row. And then you know what? Now I want to move on to the next table row, and then the next table row. Does that make sense? Okay. Okay, so we're going to play around a little bit with some BeautifulSoup. Okay, I put in the repository, there is, I believe, a data directory. Within it, there is a website that I simply called simple.html. If you open it up in a browser, it looks like this. It is as simple as we get, right? I have, it looks like a bit of a navigation over here. I have a bit of a body here. Looks like I have some sort of header element here, right? This is a muy simple page, right? Okay, so let's take a look again at what the internals are. And feel free again, hopefully you have the repository downloaded. If you don't, you can always go to github.com. Search for my name is kjam on GitHub, and I put it there quite a while ago. It's a scraper tutorial. So as I look through here, let's say that my current element is this div. And I apologize for the small font, but this div's class is navBlock, okay? So here's my current element, right? Ooh. All right, and as you can see, I have it properly formatted within HTML tags. It looks like up here is the head, down here starts the body, right? And then it looks like there's a div container, a div content, and so on and so on. But I'm here in the div nav block, right? Who is my parent? If you can open it up on your computers and tell me. Who is my parent of nav block? I apologize. Nav. Okay, here's my parent, div nav. ID equals nav. Okay, who is my previous sibling? My other div class nav block, right? So when we saw on the page, it had the two divs that had foobar and boofar, I believe, as the side, right? So that's my previous sibling. Why is that my previous sibling? Who do we share? Same parent, right? Same ancestor. And who's my child? That unordered list, right, is my child. Who is my grandchild? Or who are my grandchildren? Those list items, right? Who is my next sibling? Main content, right? And we can see that it is nested amongst, right? Why is this div header not a parent? It kind of looks like a parent. It comes up higher in the document. This is a div ID equals header. It's a div. Here's my parent. Who is div header's parent? So it's basically my cousin, right? But it's not a parent, right? So we can start to see how it gets a little bit complex depending on where you are in the document or what's easy to find. So the reason why I give you this example, you might be like, K-Jam, this is kind of ridiculous. Why can't we just start at the top and find whatever we'd like? The reason is a lot of times when you'll find when web scraping, maybe only one piece of the page is really well put together HTML. Maybe only one part is really easy for you to find 100% of the time. What you're going to find is that sometimes you have to start here and then find other things from here, because this is really the only standardized part of the page. So I'm kind of making you stretch your brain a little and think early, okay, I'm here, how am I going to find other things? So, another pop quiz. If you have IPython, then I'd like you to, from the inside of your workshop folder, the repo that you checked out from me, run IPython and type, see this is another nice fun syntactic sugar from IPython. %run is just going to run this script within IPython. If you do not, then please open this script and enter line after line into your Python terminal. You should, once you run this, have current element. It is using that same page we just looked through. It's the page that we identified that we looked at. And current element is going to be that same current element that I had highlighted in red when we were looking at the source. And I'll flip back to that quickly. I want you to, from the current element, find the text in the header. Remember, this header is not a parent. I want you to then find the lorem ipsum text on the page. And also, I'm curious, can you locate the style sheet information? So let me go back for you. Again, I want the text of the header, the lorem ipsum text, and the style sheet information. So if you are able to run that, you have current element is highlighted, this nav block. I want you to tell me the text of this header. I want you to tell me, locate for me the lorem ipsum text. And I want you to try to find the style sheet. Now my dev tools put it here. You can look in the source and see where it is in terms of the source. I will also open for you so this is family tree. So if you need to run these lines, then you may do so. Sorry, the line. Is a bit cut off. I will figure out the resolution issue that we're having here. But this is find all div class nav block, and then with a 1 at the end. I'll scroll over. So I want you to, if you have IPython or something like that, you can do this, and then you can simply, if I run family tree, and I run who's, which tells me a little bit about who I have around. I have BeautifulSoup, obviously. I have current element, which is where we're starting with. I have simple page, and I have simple soup. And what I want you to find is the header. Then I want you to find, I want you to do this utilizing the family functions. So, to give a bit of a hint, we can start to look at parents, right? We can start to look at and we can start to think about finding parents, finding siblings, finding children. If you're a bit stumped, feel free to chat with your neighbors. If you're really, really stumped and your neighbor is stumped, feel free to raise your hand and I'll come by. But I'm looking for the header text, the lorem ipsum text. How do you find it in relation to current element? And if you can somehow get to the style element. If you need the family tree, again, it's on my GitHub, or you can look here. Let me do this. Hi.
For the first exercise, I'm just supposed to use find parent header.
Well, it's not a parent, right? So I want you open up that. So I want you to tell me that. But remember, we talked about this is not actually a direct parent of that, right? So you might have to find your parent, and then find what of the parent.
This is, oh,
Yeah. The first one is pretty tricky. It's very evil of me. It's really useful to have the source of the page opened in another window in whatever text editor of your choice you like to use. If you're really stumped, let me know. Yes, you can chain the commands. You can also just set new variables. So if you want to explore the parents' relationship, you might do something like that. So I want the text of the header. I want to find out if you can get to the lorem ipsum text on that simple.html page. And I want to find out if you can get to the style element on that lorem ipsum page. The text of the header. Then if you can find the element that has lorem ipsum in it. And then if you can find the style element on the page. If you've finished and found them all, then maybe you can help a neighbor. Give another minute or two for playing around with this, and then we'll go over the answers. No, yeah, sadly, your tab support ends with your first method, usually in IPython, regardless of library. But you can set a new variable, right? I want to find the text of the header, not the head element, but the header div ID. I want to find the element with the lorem ipsum text in it, and I want to find the style element. Yeah, you know that the ones with the capitals is the old way from all of us old beautiful supers. Probably the new preferred way moving forward would be to use the ones with the underscores. Yeah, so apologies. I am very used to the old way of beautiful souping, so I am doing the camel casing, but it's also available with just underscores between the different calls, so I could. Similarly, I just have been doing Beautiful Soup for a while, so the camel case used to be the only option. Okay, so let's take a look. Who was able to find the header, the text of the div ID header? How did you do it? Somebody tell me. Anyone? So for my current element, what would I do? Perfect. I just found the header text, right? So you parse the family tree. You realize that the previous sibling of the parent held the text that you were interested in. Excellent. Okay, good job. How can we then find the lorem ipsum element from the current element? This one? Perfect, okay? So again, I'm parsing the family tree there, and I'm seeing that it's my, parents, aunt, child, child, right? So we can start to go around those elements, right? How am I able to find the style? Did anybody find the style div? How might I go about this? Like that is how you did it? Exactly. So we're going greater in depth into the library. But if I find parent and pass it a tag name, it can start to then parse the ancestors for that tag name. Let me just put this at the top. Then what I can do is within that, I can go find the style tag, right? So this started to use find. But I could also just find child style, right? So the style tag is essentially a child of the head, and the head is a child of the parent, or sorry, of the HTML document. So this is a way of finding that, right? So there's numerous ways to go about it, but you can start to see the familial relationships. Okay. Does that make sense? Was everybody successful in at least finding one of them? Okay. Okay, let me go quickly over a little bit of other BeautifulSoup commands, okay? .contents for BeautifulSoup is going to show all children, including text not in tags. This can be useful if, for some reason, whoever has built that HTML page doesn't like to use normal tags. They just put div, and then they just randomly put a bunch of text. So if you don't have something easy to parse like p tags, or if there's a bunch of random text and then a list, and you want to go about parsing the contents, then .contents works for you. .tag will find the first child within this tag. So my div.p returns the first paragraph of that div element. This is really useful in if you need to, a lot of times I'll use it if I need to test whether something exists or not. Like if div.p go do this, else go do this, right? If this div contains a paragraph element, then I'd like you to go parse it for this text, otherwise don't. It's not really very explicit, and so I tend to try and avoid it if I'm actually just looking for the first paragraph. I usually just like to use find p. But it is kind of a useful test if you just want a quick test. Next element and previous element, iterate the family tree regardless of relationship. So this, you don't have to try and understand the children, the parents. Again, I would say that this is less explicit, and if we're abiding by our Zen of Python, we want to try and be explicit. So I usually just utilize this when I'm pinging around a page and seeing kind of how it fits together. Or if I know that at the end of a series, I would like to move on to something else. But it's nice to have. Stripped strings gives me a generator that obtains all the strings stripped of extra white space within the child elements. So this can be useful if the people building the page are using white space to, or tabs and weird things like that to, basically add to their markup, and that can be really annoying. So stripped strings kind of gives you an easy access to stripping them of that. And then, as we saw, either find will find the first, or find all will find a series, and I can pass it some tag names. Now, this can be a list of 20 things. Obviously, that's not very useful. So you try to keep it to something useful. I can find all of those, and then let's say within it, I'm looking for only ones that have a class of content or something like that. Then I can utilize that as a separate one. But this then allows me to find a bunch of different pieces of the page and then compare them against some sort of logic or test that I'd like to use. So we are doing a little final quiz from BeautifulSoup. We will take a brief break after this. but first we'll do a share out. So what are two different ways now that you should have your Python shell still with your current element and BeautifulSoup in there. Remember, simple soup is what I called the overall tree. So what are two different ways to get the text of the title on the page? In one line of code, can you print all the text in the main body of the page? How many divs are on the page? Use BeautifulSoup for this. And can you print the text of just the li elements on the page? So again, if you're here, simple soup is going to be your overall tree. So simple soup is your tree. If you'd like to start there instead of current element, then use simple soup. And here is what I'm looking for. Again, if you are experiencing any difficulties, always a good idea to talk to your neighbors. Also, I can help if you raise your hand if you're particularly stumped. Oh, so it's a generator. So what you're going to need to do is use it with a sorry. I believe, I don't think it needs. Sorry. String. You're going to need to put it in some sort of list or a for loop, something like that, basically, because it's a generator object. Oh, sorry.
Is this the right line to get the count of all the divs on the page?
Mm-hmm. That's perfect.
So I noticed that when I did this, if I do the count of that gives me a different. That'll give me a different number than doing find all.
Yeah, because find all is going to find descendant.
Oh.
Yeah.
And that.
The other will not.
This will just give you
the first div.
Oh, okay.
So it's actually returning that first div, which is the container div.
Oh.
Yeah, yeah.
So does this return? I'm still very new to Python. Does this return an object?
Yes. No, it returns an element. So let's put this to a variable. Let's call it first underscore div equals that, just that. And do first div, and then first div question mark. And see, you're going to see that it's a tag, that's the string, that the length of it is 3, right? Which means because of the way it parses it, it's going to say that main div. And probably it has 2 other attributes that BeautifulSoup.
Why is the length 3?
So I believe that the length is due to the fact that the way that BeautifulSoup parses it, it's going to return a 3 tuple of different things about it.
Oh.
So, and then.
So if I do this for find all instead, it won't be a type of tag
Yeah,
anymore?
it will be a result set. So you see here, I mistyped and I did a find all, and it returned me a result set object rather than a tag. So they're just different classes within Python. So the result set is a list of the tags, essentially. We can utilize it as such. And then the tag in and of itself is just one tag. So it's just that main div.
So it's basically just a string. This one is just a string.
Yeah, it's what I've been talking about, like an HTML element. So it has its own properties. Like we can do numerous things with this. If you were to autocomplete, you can see we can find within it. We can do attributes of it. We can do lots of things like that. But it's not returning us an iterable object to then parse, right? Whereas the find all is going to give us something that we can iterate over, that we can then use to find, other content. But it's essentially doing the same thing as that. Whereas find all would give us a list.
Oh, this is the same thing.
As .div. Because it's just going to, yes, perfect.
Oh, okay. And this will give me
A result set.
Oh, okay.
Perfect.
Cool.
No problem. Okay. So, we might have not gotten to all of the questions, but can somebody tell me what is one way to get the text of the title on the page? Somebody tell me. Did anybody find the text of the title on the page? All right, tell me how you got there. Perfect. Okay. What's another way? Does anybody find it a different way? Perfect. Okay. And we get the same answer, right? So again, some of BeautifulSoup is going to be what is the most explicit way to find this so that when you pick up your code 6 months from now and it looks like gobbledygook and you haven't looked at it, then you can read it, right? And also some of it's just going to be your own stylistic choice, right? Okay, what in one line of code can you print all the text in the main body of the page? Did anybody do this? Sorry. Perfect, okay? And again, you could see that this is not really super useful. I could do some cleanup on this, but this is a really nice place to start if I just wanted to see all of the text on the page, right? So how many divs are on the page? How can I find this? I'm guessing I start with simple soup. What should I do? Perfect. Okay. We're just racing through these. We're Beautiful Soup experts. And can I print the text of just the LI elements on the page? How might I go about that? I probably need either a loop or a list, right? So, does anybody have a start of this? How do I find all the LI elements? Perfect. Okay. So we're starting to parse, and we're starting to single out who we would like to parse and what we would like to parse, right? So we're at the very beginnings. I know probably the simple page is a bit boring, but it's going to simplify for us learning some of these methods, learning some of these attributes, and then allowing us to move forward to more complex pages. Okay. I'm going to give you a brief, and I mean brief. I would like to see you back here in less than 5 minutes. We will be starting in 5 minutes. If you need a quick pee break, water, cup of coffee. I know we're hitting that time of the afternoon where all of our brains turn off. If you want to go do jumping jacks outside, that's fine. I will see you here in 5 minutes. I will be starting on LXML. If you have not installed LXML or your neighbor hasn't installed it, now is a good time to call me over and let me know all of your travails. Yes.
They keep thinking everything's working. I try to do it. It doesn't work.
Clearing out, sorry. Yeah, we're gonna. Yeah, I mean, some of what we've gone over, you can do just that. Yeah. But we'll go over more in depth. This is a great test to make sure that your LXML is properly working. From LXML, import HTML, import your urllib. If it's already there, you can just use it, or urllib2, whichever one you have imported. Grab your source from Google, and then make sure html.document_from_string source is going to return you an HTML element. No problem. So LXML is tremendously powerful, and because of that, it utilizes a bunch of XML and XSLT dependency libraries that don't come installed on your average computer. So, oh, you have, okay. Yeah, is it apt-get on Ubuntu to get the dependencies? I believe it's like lib xslt dev or something like that. Well, I will write pip. That's really annoying, but it's probably a matter of it knowing where the C dependencies lie, because it has a bunch of C dependencies. I am giving a talk at PyCon on tomorrow noonish about speed comparisons of LXML and BeautifulSoup and some other things. And LXML, you will see, is tremendously fast, but it can be a pain. So it's one of those things where if you do a lot of web scraping, you get used to the pain of LXML installs, but BeautifulSoup works just as fine, honestly, to find it. It's just a lot slower. So. Oh, okay. Do you have? Do either of you have Homebrew installed already? Yeah, sometimes it can. This is rather obnoxious. So, and you have OSX, yeah?
Yes.
And what is the error that comes up with this?
That I need to do sudo on, and when I do that, like this.
Yeah, so we have a compiler error. And you have Xcode installed with command line tools. Can you try easy installing it?
I did that here, and I got that error.
You need to sudo it.
Yeah, so I did sudo it, and then there's just runtime error.
Yeah, it doesn't have the C libraries. Let's try. Let's see if we can pass it without. I don't know why brew is ring. Oh, Mac, sometimes. Let me see if I can figure out why. We are starting in another minute.
Is there a way to get through this if you're on urllib 3 or the other ones? The only combination that seems to work is Python 3, and for me at least, so far, but I don't get that. With Python 2, I can get this far, and then with Python 3, I can get this far.
Okay, can we try brew install lib xml2 that I have up here? Let's try this one. And then try that one. You might need to sudo them if you're getting a permission error. Yeah. It's just, well, first would be from LXML import HTML. So everybody who has Homebrew but not LXML installed running these two. Brew install lib xml2. And then pip install LXML. You might need sudo if you're not using virtual env for this one. Probably also this one. I have no idea how Homebrew works on the internals. Used to be Ruby. I don't really pay that much attention to Ruby. Did that work for you? No module named LMXL. Are you in a virtual env? And did you sudo pip install LXML? So then you have to, after that one, you need to pip install LXML. All right, we are getting started in a second. If for some reason you have Homebrew installed and you could not pip install LXML, I have found somebody on the internet that has a solution for you. Brew install libxml2, then pip install LXML. If you are not using a virtual environment, you will likely need to use sudo here. Again, with Brew, I don't think you have to use sudo. I think it has its own strange environment paths. If you don't have Homebrew, you might need a friendly neighbor. Again, I apologize. Let me explain a little bit about LXML. LXML is a tremendously powerful scraping library and parsing library. If ever you find yourself in a job or position or just a fun thing you like to do on the weekends, parsing an XML document that is hundreds of thousands of lines of code, and you try using BeautifulSoup, you will cry. You will be very sad, and you will @ KJM on Twitter and say, why did you ever tell me to use BeautifulSoup for this? And I will say, hey, if it's hundreds of thousands of lines, you better use LXML, and the speed that you will get is incomparable. I could go on and on and on. LXML is just really great. It's super powerful. But because of that, it uses a couple of C dependencies that are not readily available on most people's computers. Most people's computers don't need to parse, XML or HTML that fast. So they just come without the necessary libraries, which is super for most people and really not super if you want to scrape the web quickly. So this libxml2, or I believe also for Ubuntu is my primary operating system, uses an XSLT basically parser that is going to give you that extra oomph. It's those C libraries that LXML depends on for its speed operating in the background. And I'm not a C developer, so I can't tell you exactly why it is that most operating systems have determined that these are not necessary, but probably because most people don't use their computers to scrape the web and parse XML right out of the box, right? But you will thank me later if you get this installed and working, or maybe you won't.
I figured out how to use urllib in Python 3.
Uh-huh.
It's split into a request object.
A response object? Okay, that makes sense. Yes, a urllib.
Request an error, actually.
Oh, okay. Oh, so the error is then null if no error is returned. Understood. That's
And then I
interesting.
can call URL, well, yeah, I can do a URL open on the request object.
Ah, that makes sense. That makes sense. And it's becoming a little bit more explicit. Did we get that running?
No, I got the same error.
Ay, ay, ay.
Check one out.
Yeah, what you might want to do is after that brew install libxml2, you know how it had the output of something that you might need to run in your bash? You might want to find that and run that. It might simply be that it's not accessible in your bash, or you might just open a new bash and it might work. If not, do you have a neighbor who has LXML installed? Okay, okay. If you are still working on LXML, I promise I'm not going to completely leave you behind. We can start to work on it now. If you have a virtual box, it's really easy to just apt-get LXML within any Debian distro. Sadly, it is more difficult depending on your operating system. So I'm going to move forward, but don't worry, LXML is not the end-all be-all. We'll also be talking about XPath and Selenium. There are ways to use XPath with BeautifulSoup if needs be. So, and also hopefully you have friendly neighbors who are always great. So LXML's website is lxml.de. It is an advanced library, as I've been saying, with more complex tools for cleaning and parsing web pages. It has lots of dependencies, therefore making it less portable, right? It makes up for those dependencies by being intensely scalable and flexible. So LXML is kind of like having BeautifulSoup on steroids. On steroids and yoga, I guess. Okay, so let's take a look at some of the tools that we have with LXML. So with LXML, we have something we call CSS select. When we use CSS select, if we were to say tree.cssselect div.content, what it's going to go do is it's going to find all of the div elements that have the class attribute of content, okay? So this is a great tool for front-end devs and others who know about CSS. So with BeautifulSoup, we had to pass in the class attribute as kind of a dictionary. With LXML, it's already all parsable there, and so we just need to pass the selector. The selector can even have spaces. So much similarly to how you'd write CSS, I can write div, ID, content, and then a div within that that has a class of, you know, my content and then the para. And I could go through that entire thing by just passing it a string. So you can start to see it's super powerful. That is impossible to do in BeautifulSoup without stringing together several commands. You also have find class, okay? Find class nav is going to find all of the elements with this class or find an element within this element that matches this class. What do I mean by that? When we were using BeautifulSoup and I said tree.findAllP, what did that give me? Tree.findAllP, what did that give me? All of the p tags in the entire tree, right? If I had done for p in tree.findAllP, p.findAllA, what would that have done? It would find all the anchors within what? That paragraph, right? And so I could start iterating over each of those, right? This is, or LXML is similar. A lot of these methods are available not only to the tree, but are available to the elements within the tree. So we can start to see that we can not only go about and find the div content, but then maybe we want to go find the CSS select, you know, paragraph, my content within that, right? So we can start to be explicit and parse through element by element, kind of figuring out what parts of the page we want. So that's what I mean when I say we can find the class within the entire tree, or we can find the class within a particular element. And then text content, okay? So this is going to find text within this element and all of its descendants and you know, any descendants that it has. So it's going to parse through every descendant of the element I'm calling, and it's going to return the text. This, we saw in BeautifulSoup that I could do .text, and a lot of times it did that. What you'll find, the more complex pages that you parse, is that BeautifulSoup sometimes will, if it's very nested, it might not return the text of one of those descendants. We had a pretty simple page, but you'll find on more complex pages, BeautifulSoup will sometimes just give you the top level text or just say, hey, I can't find any text. This is because it might be nested 20 elements down, and BeautifulSoup uses regex and therefore might not have, basically the engine might not be parsing through everything. So with LXML, because it utilizes a different type of parsing, is going to be much more accurate here if you need to find descendant text. Also, BeautifulSoup has a fun little function called clean HTML. What this does is it's going to try to fix errors in the formatting of that page or that element. So what it does is, because it has these powerful XML and XSLT parsers, what it's going to do is it's going to say, oh, hey, look, this person missed this closing P tag. I'm going to go put it here. This person missed this closing A tag. I'm going to go put it here. Because, you know, at the end of the day, web developers are lazy. And sometimes they miss some tags, right? That doesn't mean they're bad people. It doesn't mean that their page isn't worth parsing. It just means that depending on how you're trying to parse the page, you may need to clean it up first. Now, LXML doesn't always load a page if it's truly broken. If a page is truly broken, LXML is probably not the library for you. You're probably going to have to go with BeautifulSoup. I find it harder and harder to find truly broken pages on the internet. This was a much more common occurrence years ago People would just have, whatever haphazard HTML thrown together on a page. And browsers were pretty forgiving. As browsers get more and more advanced, and as the rendering engines become more advanced, as we enter the HTML5 and CSS3 era, then people are starting to follow the rules. That's a great thing because it means that you can use the more powerful libraries without being worried about coming across those broken pages. And you'll know it's a truly broken page if you try to load it into LXML and it just says cannot parse tree. It's going to throw some error like that. And that means if you start to look at the source of that page, it's probably got all sorts of funky things going on. OK, so let's take a look at LXML. Similarly to BeautifulSoup and passing the source, we have a way within LXML with the HTML submodule to get from a string an HTML document. So if I were to go into my IPython, and I have my LXML here. I am grabbing my source from Google, and I am doing HTML document from string, and I see that I'm getting then I have my tree element, right? And this is this HTML element. Before it was returned, now I'm setting it to a value, so I can start to look at it. And if I tree question mark, what is LXML going to tell me? Well, it tells me it is an HTML element. It's telling me where it's initializing from, my LXML, right? And it's going to tell me a little bit about the doc strings, right? Let's start taking a look at what I can do. So when I start to tab for autocomplete, I'm starting to see some things I recognize. Get children, right? I start to see iter siblings, right? I'm starting to see text content. Oop, sorry. Head, get previous, get root. So we can start to find all, find. So we're starting to recognize some of the syntax that are shared across these libraries. Okay. Okay, so let's go over the same extracting content. Okay, I have, again, my empty list of the happy hours I'm finding. In this, I'm for T in tables. And if we go back to the previous, you can see that I am here saying tree.cssselect tag. And the tag that I'm passing for this is a table, within a table, within a div, within a table, within a table column. So we can start to see that with LXML, I can already identify that part of the page by just delineating the series of CSS selectors I would use and passing it to this very powerful CSS select tag. Okay? So now that I have those tables, right? So this, again, is all the table columns that I would want. Then I am going if t.cssselect p calendar event title found happy hours dot append t.text content. How many lines of code was this in BeautifulSoup? Does anybody remember? It's like 4 or 5, right? How many lines is it in LXML? 3, right? So what am I doing here? So T in tables, what is that iterating through? All of the columns that I identified via that original CSS select, right? And you can look at this if you look at scraper.py in our repository for this tutorial. That is kind of this is a condensed version of what I'm going over that. Then I'm saying for that table .css select p.calendar event title. What is this doing? It's a logic test. What is it doing? Exactly, a paragraph that has a class of calendar event title. So if that table has it, what am I then doing? Appending it to my list. And I'm using what? Why? it formats it, but also what did I have to do with the other ones? Remember we started talking about family relationship. Does anyone remember with Beautiful Soup, what did I have to do? I think I found the next sibling, right? First I found that it had this, and then using this element, I found all the siblings, right? Why with LXML can I just use this? What does text content do? It does the content of all the descendants. So I'm now using the element that I'm actually using is the table row, right? The table column, actually, sorry, it's a TD. And if that table column has the event title, then I know that whole table column, I can just grab all the text of it. I don't have to first grab this one and then go say, okay, go find each of these and add them on. I just know that that whole column is what I want. So you see how it starts to become a lot more powerful to be able to say, hey, is this here? All right, then grab me all the stuff, then move on. So this essentially is taking me out of an entire for loop that I didn't have to use, right? Which when you can start to think of, I want to go scrape 1,000 pages in 5 minutes or 2 minutes or 1 minute, you can start to see how the more of that iteration, not only is it less of a pain for you to maintain, right, but it becomes much faster that your script can run. So this is some of the beauty of, again, nothing against Beautiful Soup, but this is some of the beauty of LXML. Let's take a look at some other LXML functions. So I can use element.iterlinks, okay? And what that's going to do, let's just take a look because it's pretty fun. So here's my tree. Sorry. It's my iterator. What does this look like it's returning? These are a bunch of tuples, right? The first, 0 index of the tuple is the actual element, right? What's the 1 index? It's going to tell me what it is. These are all hrefs, right? But if these were a different type of link, then I could see that here, right? Maybe an anchor tag. And then it's going to tell me the location that is sending me to, and then this is going to tell me, I forget exactly what the final number is for, but I'm sure it's in the documentation. I'm sure we can look it up very quickly. But this is telling me, look, it's asking me, do I want google.ca to be my preferred domain? It's asking me, do I want English ads? And these are all things from google.com that it found in just iterating the links. So you can see how this can be a little bit powerful and that it can find anchor tags and other things that if I just did find all A, I might not be able to find. The .get, do you remember what we passed here? With Beautiful Soup, what did we use get for? Yes, I wanted the attribute. So I could do an anchor tag .get href and return the href, right? Return the link that it's going to link to, right? So this .get is going to allow me to get at those attributes. I also have iter descendants. This is a great thing if you know that you have a section of content and all of the descendants matter, but you don't necessarily know what form the descendants are going to use. So you're just going to iterate over every descendant. So again, instead of finding children and then going through those and maybe ending up with all the descendants and maybe not, depending on how simply or complex the relationships are in the document, this is going to just go through and iterate all the descendants. And then element.attrib is going to list the key value pairs of the elements and the attributes. So if I were to, let's just find the first link. So here's my link. Oh, sorry. That's not going to work with that. Let us. And now I have my link. Sorry. And I can start to see that it has the attributes. So I have my hrefs and I have my classes. So this is how you can start to determine, sometimes when I'm exploring a page with LXML and I'm finding out, different things about how to parse the page, I can see how LXML sees the page by looking at the attributes there. Okay, we're going to dive into some LXML. So again, if you do not have LXML installed, I would like you to look on with somebody next to you. I want you to use the source of python.org. I want you to tell me how many paragraphs are on the page. Then I want you to tell me what is the text content of the div with the class shrubbery, and what are the links in that same div. I want you to also tell me what is the text of the code elements, and there is a bonus question. Are there any forms on the page? A good starting point, will get you going, is we have hopefully our import urllib to. We have our import HTML from LXML. Oh, sorry, other way around. Then we want to and then let's get our tree. And we can start to do that. So I'll leave that up. How many paragraphs are on the page? What is the text content of the div with the class shrubbery? What are the links within that same div? There's a div with a class shrubbery, because obviously. And then what is the text in the code elements on the page? These are literally code tags on the page. Bonus question is, are there any forms? Again, if you don't have LXML installed, help your neighbor. Yes. And for the bonus question, if you already answer it, there's also a shortcut way. So see if you can find the shortcut way. Give you another minute or so, and then we're going to share out. Again, you can raise your hand if you're truly stumped.
Interesting. Does that mean that I should use the same CSS rules when identifying the elements? Like, by this I mean find the element div that has a class shrubbery with that. Does that make sense? Is that why this is named CSS select?
Yeah, because it's using the CSS selector to parse through.
Okay.
So if you just used div instead of div.shrubbery, what happens?
Oh, it'll find all of them.
Perfect. So you're explicitly defining that as the CSS selector.
Okay.
Yeah.
I thought I was looking for CSS only.
Oh yeah, no. It behaves much as CSS does within the rendering engine.
That makes sense.
Yeah.
For the second exercise, I'm not sure what to do after that.
Okay. So can we? So what does that give us?
That's going to give us a list of all the divs with that class shrubbery.
Okay. So if we have this then list, then how can we find the links within those divs? Or if we wanted to find the links within the first div.
That's the thing. I don't know the.
So we can 0, right? That's going to give us the first element. And then if we wanted to find all the links within that, what would we do?
All the links within this.
Yes. So let's use CSS select again. And how will we find links? How will we select them with CSS? Perfect. Try that. Perfect. Do you see what we did there?
So then
So
this gives me all the links in.
in that first div.
So then how?
So we could create a for loop, right? So if we did, how would we loop over all of the div shrubberies?
So back up to here.
How could we loop over all of this?
I'll do something like that.
Perfect. Then what would we do? We need a colon at the end.
Then.
So then we have div, right? Then what do we do here? All right, try running that. Oh, let's print it, sorry. So now we're starting to show all of the A tags within all of the div shrubberies, right? And if we wanted to, we could create a list comprehension out of this or whatever, but we're starting to get at the content that we would want.
So then what's the function to retrieve the contents out of those A's?
So if we wanted to instead print the, let's say we wanted to just present the .href, how would we then go about printing that? So we have the A. What do we use to get attributes? Do you remember .get?
Oh.
Try utilizing .get there.
I forgot the
Yeah, it's a lot of methods. It's a bit overwhelming at first. Try that. Oh, okay, sorry. So we're going to have to build a generator there. So then we could do for, we would need another for loop there, essentially. Dot. Find isn't going to work there because find is going to use XPath, yeah. Perfect. What am I looking for?
Wait, I'm already in my A, right? So
You're not yet, right? So you're in for div in CSS select div shrubbery. For A in div CSS select what?
oh, A, oh.
Mm-hmm. And then in that next for loop, you can, or you can just put a space and then, no, you need a colon still, always with a colon. But then you want to print, you're on the A now, so what are we going to do? A dot what? Perfect. So this is going to start to return all of our links. Awesome, good job. Okay, so how many paragraphs are on the page? Somebody tell me. How did you find out?
So what I did is just a len of tree.css select p.
Okay, so we can see, we can use CSS select to find the number of paragraphs. And then we can try to use the len to find that out. All right, how did I get the text content of the divs with class shrubbery? What should I type here? So again, I'm using a CSS selector here, right? So this is going to find all the divs that have class shrubbery. What am I going to do then? Somebody tell me. Perfecto. And this is going to then print out for me all the text content, right? So I can see that it's starting to have an iterator there, right? What if I wanted to find all of the A tags here? What should I print? Div dot, sorry. That works too. So I can start to see, look, I have all these links. If I wanted to iterate through all of them, I could use the 0 index of the tuple to get to the element. Otherwise, I could just parse over to the second one. If I just want to see, oh, look, they're talking about IPython. Yay. They're talking about SciPy. They're talking about pandas, right? They're talking about OpenStack. So there's numerous ways to get to that. What is the text in the code elements? How might I find that? CSS select is my friend right here. What am I going to type in here? What is this going to do? The text for all of those. Right? So we can start to see. I mean, obviously, this is a bit gobbledygook. So can somebody tell me if there are forms on the page? Is there a form on python.org? How did you find it? Perfect. It's returning my element. There is also, did anybody find the shortcut? Yay! And we can see by the hash that we're talking about the same form. So LXML comes with some nice little build-ins, like finding all the forms for you. Why is finding forms useful when you're scraping the web? Sorry? Yeah, half of the pain in the butt of using the web is filling out the stupid forms, right? I mean, hopefully most of us use something that has the form autocomplete, but let's say we're building a scraper and we're gonna have to register ourselves, or we gotta fill out some form to get to the PDF download or whatever we want to do, then this can start to give us some of the power of those things that takes, again, the pain out of our life and puts it on LXML and the kind core developers that they have. All right, so XPath is what we're going to go into next. XPath is a really nifty way that allows you to turn HTML into an easy to parse XML node language. So we've been talking a lot about nodes, and we've understood these family relationships, so we know that HTML kind of follows that same syntax of XML, and XPath is going to take it to the next level. LXML has a built-in XPath parser, and there are several other libraries that have this as well, including HTML5lib, uses LXML XPath as its main one. Scrapey, which I'm sure some of you have looked at, is a great spidering and crawling infrastructure that uses both LXML XPath and Twisted for intensely fast web scraping. And XPath in and of itself is just really used across a lot of the web scraping languages as you start to get to know them better. It's really easy to learn, and it's very portable. So XPath is the same everywhere. It's a standard, it's a protocol. And so, or it has a standardized way of interacting with it. It's not a protocol, but it allows you to then use your XPath knowledge no matter if you don't like LXML and you want to use it with HTML5lib, or you just care about Scrapey, or whatever other things, you can use this across a lot of different libraries. And then also with a little bit of regex knowledge, and this is not a lot, I am not one of those regex experts that can easily write a line of regex to match anything, but with a little bit of knowledge there, it can become very powerful. So we're going to take a little bit of a closer look here. So XPath uses a similar language. So if I am in an element and I am accessing something else via XPath, if I were to use /body/p, it would match all the paragraphs in the child body tag of my current place. So this is a great way to start in terms of if I was at the root, right? I say go into the body and find me the paragraph tags, and that would return all of them. We start to see the /, right? 2 // p/a would match all links in any paragraph in any child. So the syntactic sugar, so to speak, from these 2 / means I'm going to try and match all of the things that I can find from the root tree all the way down to the bottom. And so this kind of is starting to blow out of the water our child relationships. With XPath, we can kind of just say, give me them all. I'll figure out whether they're children or not children. But then we can delineate, I only want the A children's of those paragraph tags, right? And so that's going to give me that. Here we start to see a little bit more of what's happening behind the screens. A /p, what does this remind you of? How many people use the command line to traverse directories? Yeah, so we're starting to see that it's a little bit more similar in terms of how it utilizes similar to a bash command, right? And this would match all the paragraphs in the parent element. So we can start to see that it has some of these relationships, right? And we can also start to see it's very sparse, right? Doesn't have a lot of extra language in there. So more on XPath. The @ symbol will single out the attribute. What do you think this does? Somebody take a guess? So I'm grabbing all the anchor links. Then what am I grabbing from the anchor link? Just the href. So this is what you're seeing when you run LXML, you know, and you're finding all A, and then you're going .get href. This is what you're doing. You're just doing a fancy way of saying the same thing. But this is the power behind the wheels, so to speak. So these could I use them for classes? Ooh. Yeah. Could I use them for inputs that have names? Yeah. I can use this to start to parse out any attributes that I want. I could use them for style links. I could use them for JavaScript links. I could use them for anything on the page. A star, true to regex, or an A star is a wildcard variable. It's going to match any sub-elements or any attributes of the element that you're currently at. So this is where you start to become very powerful. And this is great. This is a great way to first explore a page with XPath. You don't know what's there? Simply throw a star at the top element, and you can start to see the makeup of the page. Some other interesting things that we'll be playing with in a minute. Text, comment, node. These all will match any of those elements within the current element. So --p is, again, going to find me all of the paragraphs on the page. /text would match all of the text in all of the child paragraphs. And I did it in one teeny little line of code. If I wanted all of the comment data, then I could do that. Node is what XPath uses as a catch-all. So node could be a comment. It could just be any subnode. So if you're dealing with XML in and of itself, and you have, somebody's written their handwritten XML, and every business has then a name attribute and a address attribute and those types of things. You can pass /address, or you can just pass /node to see all of the nodes, right? And so this is where we start to really get into kind of the core depth of what's happening here. And this is part of why XPath is so powerful, why LXML is so powerful, because LXML relies on XPath to a very deep degree. It's also why it's a pain in the butt. Okay, so let's run. I have an XPath intro here. So in my library, you should be able to run XPath intro. We have now an LXML tree called simple tree. So if I call simple tree, it's there for me. Let's do simple tree.xpath, and okay. So this is that same simple page. So to find all the paragraphs, it was a simple line. How about so now, within all the paragraphs, find just the text. And it returns me a list. How many lines was this when we were trying to find it earlier? It's quite a lot, right? I mean, we could have found it in different ways. But we start to see the power behind really understanding XPath and understanding the XPath relationship of a page. Okay, so what are the direct children of simple tree? How might I find this? So if I just simple tree, sorry. I can start to see all of the nodes, right? If I were to, what's the wild card? First, let's just do a star, right, which is going to tell me just those. So I can start to see, with my tree, I have an element head, and I have an element body, right? What if I just wanted to see the children of the body? What would I type here? So we can start to see how easy we can explore. All right, the body has a div. I wonder what's in that div. Oh, I guess that div has another div. These are different hashes, right? So these are different divs. Okay, well, within that body that has a div, what's in there? Oh, now I start to see the other divs, right? So this is a really great way, it's a really powerful way, I think, of first parsing a page and starting to get to know it and play around with it when you're first scraping and figuring out how to best find what you're trying to talk with, right? I could also do something like return all the divs and return all the text of the divs. And then you can start to see, how could I get all the text that is not a new line, right? And you can start to go into that. So we can start to play around with that. All right, let me get back to a couple other things about LXML. So every LXML element has numerous ways to utilize XPath. If you were having trouble using find or find all, and even I slipped up and sometimes I'm doing BeautifulSoup all morning and in the afternoon I switch to XPath and I'm trying to use find, why isn't it working? Well, it's because find uses XPath, right? So find is going to look for those different relationships via XPath markup. Find all is going to do similarly. So find will find the first, find all will find all of them, and .xpath is what we've been using. Use whichever makes the most sense to you or the one that is the most explicit depending on your code, right? XPath obviously will always alert people to the fact that you're using XPath and that you are using XPath with whatever element. Okay. So using that simple page, hopefully you're able to run it. If not, I will put the series of commands that you need to do to run. Can you show all of the texts that are in lists on the page? Can you find all of the attributes on the page? Can you find any links on the page? And can you get to the style sheet information? Extra credit? Try something like this. Element attr equals foo. Instead of this attr, I want you to use a class. And I want you to choose one of the class names. So you just do @class equals one of the class names. So I want you to find class with content block. Extra credit is try the above without the open bracket, close bracket, and use just a slash, similarly to how we have been with XPath, to separate out the attribute. And what kind of response do you get? So, just to quickly have this open, if you were able to run XPath intro, you should have that. I wonder if I can run cat in here. Okay. So if you do not have this downloaded, then you can, from LXML import HTML, simple page equals open. You're going to have to grab the simple.html, and then your symbol tree is there. But this symbol tree is where you can start. So our first one is, can you show all of the texts that are in lists on the page using XPath? If you're stumped, feel free to raise your hand. Okay.
I didn't realize about the install stuff.
Oh, okay.
So, and I have a Windows machine, and after
Oh no. Oh no. Yeah.
So I was just curious. I've in the past I've used these two, Sax and XML DOM, mini DOM, and eTree, and I was just wondering, since they're core to Python, what's the, I mean, like I guess a compare and contrast against XPath and this like sort of antiquated, I guess is what I'm saying? Or is it worth using? Or
I mean, they're worth using. It kind of, at the end of the day, depends on how much power you want. The nice thing about LXML is it comes with a lot of other helpers and other things, so that if you're parsing different parts of the web, it may or may not, it basically does some of the lifting for you, right? But you can pass mini-DOM is one of the ones that you can pass into HTML5 lib, which is another one of the popular ones. But if you look at the speed comparisons, using XPath with LXML is far faster than mini-DOM. So it depends. I mean, at the end of the day, if it's, you know, tenths of a second, that might matter to you. It also might not. But
getting ramped up on a new library.
yeah, LXML is just really powerful in and of itself. So it does have a lot of like extra things added on that you don't just get from mini-DOM and from Sax.
So would you say the most popular one?
I would say it's pretty popular. It's kind of started getting popularity 4 or 5 years ago because I don't know if you know, Ian Bicking wrote a series of articles on, you know, why LXML is the best parser, so to speak.
Yeah.
But if you get, if you start parsing like a lot of different pages and you want something that's powerful and speedy and that usually doesn't mess up, it's kind of like a fairly standard. HTML5 lib is also very good, but it's a little bit newer and a little bit less robust. And then Scrapey that I will reference and that I'll be talking about at my talk at PyCon tomorrow is LXML XPath only with twisted, and so it's like intensely fast. It's more of a spidering, but if you need to spider or crawl in kind of that old school way of like following links and going to the next one, it's tremendous. Nothing is as fast as it really. So it's kind of fun to use.
Another question I had, sort of what I have this right here, is some of the XML. I'm not a big XML person, just because I haven't needed to, but it's kind of coming into my life more and more. You know, they have the definition of like the style definition that's like at the header of the XML document, and then you can look at that. So before you start writing code to like parse an XML document, is that something that you can just look at, figure out what the format is, and get the code out without really having to inspect each document separately?
If it's updated and used properly. Yeah, and a lot of...
That's the purpose of that. Right?
Yes, of course. And a lot of them, the good news is that a lot of them also have namespaces, right? So if you run into namespace issues, LXML handles a lot of those namespace issues. Yeah. Yeah. So sometimes you'll have, everything is namespaced with whatever, and you're trying to parse it using one of the more simple libraries, and everything has this annoying namespace string. LXML handles some of that with it. There's a LXML.ns map for elements that tries to configure namespaces for you, essentially. So it has some of those nice little build-ins, just because they understand it's a pain. No problem. Okay. So, can somebody tell me how to show all of the lists on, all of the text that are in lists on the page? What am I going to do? Somebody tell me what to type. I don't know. Simple tree. I'm using my XPath. What am I typing here? Uh-huh. What if I did this? Will that work? Nobody knows. Ha ha! I have it. Aha. All right. Somebody tell me, using my XPath, how can I find all the attributes on the page? Sweet. It's all my attributes. Would this work? No. Why? Yes, this is the attributes of what? What is this? That's like my root document, right? Because this is going to be my doc type, right? I'm dealing with XHTML, right? Okay, so are there any links on the page? How would I find them with XPath? No, sad face. Want to make sure, yeah. Okay, then can you get to the style sheet information? What am I typing here? What's another way to get to the style? I heard somebody say, right? So depending on where you are, where my tree starts, right, which for this is before the head. The head is not a direct child of where I'm starting, so I'm saying find the head, find the style. For this, I'm saying just go find all styles. So one of them gives me 2, one of them gives me 1. But we can see that I am matching one of them, and then I have another one. We could investigate that further. But I do want to get to the extra credit. So can you find me using, I said that element with open bracket, close bracket. So I wanted you to find me the divs that have what? What did I want the class equal to? Stay with me. Okay, so what am I doing here? I'm finding all the divs. What am I passing with these weird brackets? Class with an attribute, okay? And I'll, oh, sorry. Oh, sorry. I'm using contains logic, my bad. Okay, so can we all, hold on, let me clear and then do this. Okay, so I say, hey tree, find me all your divs where their class equals content block. What does this remind you of? CSS select. This is literally what LXML is doing every time you run CSS select. So explain the element to me.
Like if this div was in class A and class B, the attribute that A space B, would you match on just one?
And that's where you saw me start to mess up and do something like this. So we have this contains, which is very nice to have. And it starts to give you the power of this might have 10 classes. I just want to make sure somewhere the class has this, right? Otherwise, what it's looking for is it's looking for an exact match, okay? So if you tell XPath the class is this, it's only going to find the class that. If you tell XPath, hey, you know, it probably has this, it might have some other things, then you're going to use contains, right? And you can start to see that it gives you a little bit more flexibility. With my extra credit, what does, oh, sorry. The add is an attribute. So we have tags and we have attributes. Tags are our main tag. It's our A tag. It's our P tag. It's our div tag. And then our attributes are div class equals content block. Href equals link. You know, whatever it is. Okay. So I said take away those and do this. What does this return? Did anybody play around with this? So instead of using the brackets to pass the class, I'm just doing a slash. But I'm passing this class equals content block. What does this return? True. Okay, so we have a logic test here. Sure, we could say if len of this blah, 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 or we could simply pass this, right? This is a nice way of using XPath to parse it for us in a very fast manner and tell us whether something exists or not. And you could see utilizing this similarly to how I did the CSS select in my parser. So in my parser, I said, hey, do you happen to have a paragraph that has this class? If so, just tell me yes or no, and then I'll keep going. And I could do it here with probably slicing tenths of a second off my time. Now, you say tenths of a second, KJM, does this really matter? Probably not for the average scraper. However, if you're using a scraper where you need a lot of power or you're trying to do a lot of pages in a short amount of time, then this knowledge of XPath comes in handy. Also, knowledge of XPath comes in handy if you're literally shaking your fist at your screen. Why can't I find this? When you start to explore it using XPath, you're starting to see how LXML sees the page. And the more you understand that, the more you're able to use it to do what you want it to do. 'Cause sometimes the page, in the way that these rendering engines with LXML see it is different than how you see it rendered on the page. Maybe JavaScript has moved the page around. Maybe something else is being accessed. There's a million reasons why. But this is going to start to give you the power to kind of look at how the page is being parsed in the eyes of the library. It's also tremendously powerful and, again, portable across numerous things. So let's take a look. Hopefully, everybody's still with it. BeautifulSoup and LXML scraping limitations. Not every site has HTML that can be parsed, okay? Sometimes we have DOM-loaded content. What does that mean? What's DOM-loaded content? I gotta have at least one front-end developer in here, come on. Perfect, right? So for LXML and for BeautifulSoup, I'm using urllib or request or whatever, and I'm going to say, hey, go get me this page. When do you think it snags the page and stops reading? When the response is closed, right? The response closes after it's done loading. So any DOM-loaded content, sorry, you're out of luck, right? Really broken HTML and XML. Again, your go-to here is BeautifulSoup, but sometimes even that won't work. If it's really broken or if it has weird JavaScript injections in odd places, you're probably not going to have a lot of luck. Proprietary or login required can be difficult. Depending on the login flow. If the login flow is a simple form submit, we could curl that, right, at the end of the day. Or we could use urllib. But if the login or if the way to access it is through a series of links that they're going to take you through, it's really not going to work out for you trying to use these libraries. Or if you have any JavaScript form interaction. As you can see, these libraries kind of get the page, and then that's what you got. So again, it's really powerful for a lot of things. It doesn't work for everything. So what are we going to do then? We could learn Node.js. Node.js has quite a lot of libraries here. Or we could use Selenium. Okay, so Selenium is an open source Java project, and it has a Python binding library that allows you to basically explore the web via your browser. Probably numerous of you are familiar with Selenium when it comes to QA. Please tell me somebody's heard of Selenium testing and things like that. It's really great for that. But you know what is also really great for web scraping, and it has quite a lot of good things in the Python library. So Selenium comes built in with Mozilla Firefox support, as long as you have that installed. I added that to the documentation. It also has a Chrome driver, and it has an IE driver, and it has a bunch of other things. So let's try opening up a browser and taking a look at it. So I am going to go in here, and I'm going to run startselenium.py. Which came as part of my thing. So, waiting. Look, here we go. What did it do? It opened up a browser for me. Okay, if I go back to my terminal, I'm actually going to exit my terminal and re-enter it because I have quite a lot of things in my who's. So I have a new window now. And if I run who's, what do I have here? What is this variable? I have a browser, right? It is a type WebDriver, and it's from Selenium, right? Then I have a WebDriver, which is a module. So I simply have this browser, right? Let's talk a little bit about this browser. Okay, Selenium, here's some basic functions. Get URL is going to go to the URL. Element.click is going to click on the element that you have selected. For each element, you're going to have numerous properties. The element's going to have a dot location, which are x and y coordinates. It's going to have a dot parent, which is the parent element. Sometimes this parent element is the browser, depending on how you accessed it. It's going to have a tag name. What is the tag of the element? These are all going to be useful things to know. So, let us, within our, first I would like to have us play around a little bit with, really? Oh, this is fun. Okay, so I have my browser here. How do I get a page if I wanted to go to python.org? All right, so it has returned. What can we see here? Hello, welcome to python.org. Okay, let's say, so I'm going to see if there's any inputs here. All right, it looks like I found an input. We're going to go over these in further detail, but I have my input now. Just to show everybody, that's my input. Okay, I'm going to import another helper library. Okay, in the background, do you see what my browser is doing? I just input that. All right, and you can see my browser in the background, or I don't know if you can see, is now searching python.org. So with a couple of things, I can easily do something. I'd like to give you a quick demo of something that I included in this. Mine is going to have also my login, and I actually don't know if this is going to work on this screen resolution, but I could try. So I gave you a scrape Netflix, and what that's going to do is it's going to go to netflix.com. It's going to attempt to find the sign-in button. Upon finding the sign-in button, it's going to the sign-in. It's going to input my member details. It is then going to load my profile. Then it's going to go to my Watch Instantly home, which sadly is blocked. At this point in time, however, I am going to attempt to scroll down, and this is where my resolution is probably sadly going to fail me. However, if I was able to run this in a normal resolution screen, it is going to go down to the list called Top Picks for Katharine. Oh, and it's going to iterate over those lists. When it finds those lists, it is going to grab the information from them, and it's going to keep going through them until it has reached the beginning of the list. This is not information not available via the Netflix API. There is no way for me to get my top picks according to Netflix, and this is sadly where my resolution is going to break my code. However, if we weren't in this much of my browser and instead using a maximize window, we would be doing all sorts of magics right now. And then I can easily then use that list to email to me, hey, guess what? This new thing is in your top picks. Netflix says you should go watch it. And all of this, I didn't ever have to log into Netflix. And honestly, I didn't even have to have a streaming server, or sorry, I guess you have to have streaming to see WeHome. Anyways, you can start to see that Selenium gives you some of this power that might not be available via an API, that might not be available via LXML or other things like that. So let us take a look a little bit. And you can see these taking too long, as you can see in the script. And if you have a Netflix account with streaming, feel free to happily, I put some global variables there so you can use that script for your own purposes. But as you can see, Netflix doesn't allow me to see the top picks unless I log in. It's just part of probably their proprietary logic, which is fine. But I can write a scraper to do it for me. And as you can see, with the scrape netflix.py, it's like maybe 80 lines of code or something, and probably could have been condensed to more had I wanted to kind of make it a little bit more clever and a little bit less instructive. I tried to keep it as instructive and basic as possible. So let's take a closer look at what I'm doing. I switched to Chrome because I was finding that my latest upgrade of Firefox, which sadly happened this week, actually broke this script for me. But either way, I can use the Firefox usually. Then I'm telling it to go get Netflix. Then I'm using this browser.find element by link text, sign in. And then I'm clicking on it. What do you think that's doing? It's clicking on that sign in button, right? Which I found out was an ahref hidden underneath there. So I can just say, hey, the link text says this, go click here, right? This allows me a little bit of flexibility here. If Netflix changes the class name, is my script gonna break? Probably not, right? So Netflix can probably undergo a redesign and I'm still gonna have some of this power, right? Then my email is going to be browser find element by CSS selector input ID email. So I'm using my CSS knowledge. I'm saying, hey, go find me the email input. My email, I'm doing what? Send keys. I'm passing in my email. The password, I'm finding that password input. Password, I'm sending the keys. My password and then keys return. What does keys return do you think? It just enters it, right? It's like passing the return key. So what you'll find with a lot of the internet is, thankfully, once you get to the end of a form or the end of a required form, you can just hit return. And you don't even have to bother finding the button element and clicking on it. You know, you can do so, but this might be, again, something where if they change where the button is, it's always going to work, right? Yes, yes, indeed. So, you know, depending on how secure you'd like your Netflix, we can, you know, use HTTPS, right, and try and trust it. Or we can determine, you know, that maybe Netflix is okay to share with the world. So in your browser, then I have this implicitly wait. And we'll talk a little bit more about that. Mm-hmm. No. There's drivers for nearly every browser. So if you go to the Selenium pages, or a lot of the browsers actually have their own Selenium pages, then you just merely need to install the driver for your preferred browser, or whatever browser you'd like.
And that would be a Python package that would have to install in addition?
No, it's usually the driver package is usually just allowing it to be bash acceptable. So it's mainly just putting it in your bash so that Selenium can just talk to it. Because, you know, Selenium is primarily Java. We're using a Python Selenium library, but most of the internal workings of Selenium are Java. So some basic functions of Selenium. We can find element or elements. What do you think the difference is with finding an element and elements? What's the difference there? We've been talking about this all day. First item or a list, right? So again, it's going to start to give us those. So we can do by the link text, right, which we saw me do with the sign in. We could find elements by partial link text. And so you can think of this as the text contains, right? This is tremendously useful because what if you really only know that it's going to say about somewhere, but it may have a space, it may not, it may be capitalized, it may not. So we could start to see those. We could even see directions links there and things like that. We can choose the CSS selector. So this is just like with LXML CSS select. We can choose by a tag name. So we can just pass all the A, all the buttons, all the inputs. We can select by XPath, okay? Yay, I know everybody loves XPath. Maybe not the first time. You will come to love it. It's like, some sort of awful relationship that eventually gets better. Or you can find it by the class name. So this is, again, CSS related, but it is going to, similarly to using the by class, you're going to be able to find all of the things. So whether it's a div, a UL, a P, all of those that share that same class. So ghost type the page. I hope we have some Bay Area hip hop fans here. So send keys is useful. So send keys is going to, for any text field, you can find that text or that input element and send it keys, right? Element send keys my password. Element send keys, here's more, and then I'm entering. And I'm returning, right? So you can pass these as a series, as a tuple, essentially, and it can grow as large as you need it to grow. You will find that there are many keys available. So I have this link here. Again, I will be publishing these slides. But it can give you up-down arrows. How might you use up-down arrows? A select or a radio button, right? So what if you need a radio button, something on or off, or check a checkbox, things like that? You can send it up, down, or highlight arrows. You can send it capital, shift key, and something, things like that. What was your question? Can you, sorry? Yes, yes. I believe that there's some sort of combo. Most of the operating systems have some sort of key combo for that. So I would have to look at it, but you can send command and things like that, so which a lot of times will give you the same functionality. Is there a deduce CAPTCHA? I know that people have tried to find their ways around this. I myself am hopefully now, I recently quit my job and am forming my own company, and a CAPTCHA Eater is one of the first open source projects I'd like to work on. So I'm going to be trolling around PyCon, finding other people who want to build this CAPTCHA buster, because it obviously is a big pain. And particularly if you want to parse somebody big that's going to track your traffic, there are definitely ways around it, but it can quickly become very limiting if somebody is basically throttling you. Right? And so Google will do this a lot. If you want to ping Google with a bunch of different things, eventually it's going to be like, I want to make sure you're a human. Well, sure, I'm a human with a keyboard. It's not a problem. But there are a couple of small libraries. There's not anything built into Selenium as is. I'm hoping that more people start working on it as more people get these tools available, and we can CAPTCHA crush all together. I'm sure then there'll just be something else that we have to fix. And then you can also element.clear, so to clear the enter text. This is great if probably not going to be part of your scripts unless somebody's pre-populating a bunch of forms, but even then send keys usually will just overwrite those. But if you're playing around and you mistype something, it's nice to know that you don't have to refind that element. Okay. So let's take a closer look at my Netflix script. What I did was first, I loaded Netflix, I logged in, and I went to my Wii Home. And then I found the row called Top Picks, and I made sure that this was my Top Picks row for Katharine, which again is not accessible in any other way. And then I did movie recs equals toppicks.findelements by CSS selector div.ag movie set, div.ag movie. What do you think that's doing? perfect, right? And it's going to get all of them, right? Because I did find elements. So what I found was all of those little movies were div AG movie, but first I had to find the row I cared about, or else it would give me all of the movies on the whole page, which I really don't care about. And I knew that it was going to be within this AG movie set, and that just helps me find it in a fast and very accurate manner, right? So now I have that set of movies that are my movie recommendations from Netflix. Then I'm saying first movie equals movie recs 0 index dot location. What is this doing? What did dot location do again? Do we remember? It's the XY axis of my screen. So when we think of axis, the Y is here and the X is here, and it's going to give me the XY axis of just that first movie, right? Which is scrolled down and a little bit in. Then I'm doing something, scroll down equals my action chains, passing my browser, move by offset, 10, first movie.getY, which is returning my Y variable, minus 10. Scroll down dot perform. What might I be doing there? Just in regular. Moving the mouse, I'm scrolling down to that first row, and I'm moving by an offset, right? And what I found is, and what you'll find a lot with these scrolling, is that moving around the page is tricky, and you have to be patient. So with a lot of these pages, and what I found when I was first writing my Netflix script, is I just scrolled to an element, which is an available function. And then what I found is that the Netflix then gave me a bunch of rollovers of, you know, the new titles and this, and it would center it improperly. So sometimes when you're playing with these browser functionalities and you're moving around in these action chains, which will go more into depth, you want to just be a little patient and find what works. And what I found worked best with Netflix and the amount of scroll over, hover overlays they have going on, which is quite a lot on their pages, that moving by offset was the most trusted and accurate way cross-browser-wise that I could move to the row that I cared about and navigate around them and have all of the elements able for me to see. Because with Selenium, if you can't see it and you can't interact with it, then you can't code it, right? So you're, again, parsing the page and you're moving around very visually. Action chains are a class that provides a way of stringing together one or more actions and then implementing them. So we can move by offset, which is what I chose to do, but I did find a location first. We can move to an element. This is going to move to the direct center of that element in terms of X and Y. So it's not always what you want, but it is what you want if you immediately want to highlight or click that element or put something there. And then you can also move to element by offset. So you can pass an element and you can pass it an X and a Y. I could have ended up doing this, I could have done this as well, but I found that I wanted my X axis to not move really by much. So I decided to code by offset first. So you can start to see that these are, you know, pretty, that they have a lot of options for you. So waits are a great way to make sure that the page and DOM are all properly loaded. We have two different kinds of waits with Selenium. We have explicit waits, which means you tell the browser to wait for a particular element or other condition for up to 10 seconds. This is great if you are waiting for the page to load, and it's going to load something and it's going to pass something in via JavaScript, right? Then you can tell it, hey, wait until you see this, then go click on it, right? Implicit waits are going to pull the DOM for up to 10 seconds and then continue. So it's basically just going to wait if there are any requests that are still completing, like CDN requests or other things like that. It's going to wait for them and then continue. So as you can see, this is kind of the good way to go if you're writing explicit code. But if you know that a page just takes a long time to load, you might want to use this. So, wait, why 10 seconds? After 10 seconds, I think Selenium just, you know, they wrote it into that's the maximum you can utilize for there. I think that the ethos behind that is if it hasn't loaded in 10 seconds, it might not ever load. Either you have a really slow network connection, or you can basically try catch and then catch it and wait again if you need to. you cannot, depending on how visible it is, right? So you would imagine if you tried to click something that was off the page, you wouldn't be able to click it if you had a browser, right? So you can't do things like that. But you could scroll something into view and then click on it. So Selenium has kind of the power of both of the types of scraping. It can do anything in the box it can see, but it also knows about stuff it can't see. But you might have to scroll to it first and then click on it. So those are the types of interactions that it can support. And depending on how complex the page is or what behaviors it allows, sometimes things are clickable outside of the browser. Rarely, right? But you can almost always get Selenium to move there, and it has quite a lot of good logic around that.
So when it's not the browser, can we tell it to stop the browser in full screen mode?
Yeah, yes, you can maximize at any point in time. So it's just a browser.maximize, which is really nice, again, if you're dealing with things off the page or if you want to, have your real estate. And again, if you have an even larger monitor than I do, and particularly than this paltry resolution I'm getting over here, then you can imagine that it becomes very easy to then parse around. So you could even have this running on a huge monitor at home in the background, doing things for you, right? So if we take a closer look at my weights, this is one of my explicit weights. And I'm saying try, so I have it in a try except block, and I could be more explicit here and find the exact import and find the exact error. I want it to be fairly clear, but you can see that this is, I'm assuming it's taking too long if I'm passing through this. So with this, I'm saying wait, I'm passing it the WebDriver, I'm passing it the max seconds until ec.element to be clickable by ID Bob movie. So what does that mean? EC, I will give you a hint, means expected condition. Somebody try and translate it to me. What am I waiting? Exactly. So I have some element. It has an ID of what? Bob movie. And I'm waiting until it can be clickable. So Netflix, as we all know, or if not, we didn't know, as we saw, when you roll over it, there's a little window that pops up. Bob movie is the name of that window. I'm waiting for that to be clickable. Why would I be waiting for that to be clickable versus like visible? I'm triggering that event, and why do I care that it's clickable and not just there? It might, well, eventually, right, I might, and it might not be loaded yet. So JavaScript, if we look at what Netflix is doing underneath the covers, is every time I hover over something, it's popping up this ID, but it's reloading it with new JavaScript results, right? It's calling its API, and it says, oh, by the way, Katharine rolled over this, now we got to go get this movie. And it's just passing an ID and doing some JavaScript AJAX requests in the back end, right? And so I want to wait for it to be clickable because that's when it's going to definitely be readable of the element I'm interested in. So you'll find sometimes is your Selenium gets so fast, you're faster than the pages, and it really is not very useful to you then, right? So sometimes you want to wait for something human-like, like a clickable element or a visible element, depending on how it loads, to show up first, then grab the data. Right? And you saw once that window appeared, you saw it would kind of wait for it, and then the second the data loaded, it almost automatically moved down to the next one. And that's the speed of Python versus if you or I were doing it with our, with Mechanical Turk, and the fact that this can be so much faster. Then you can see I'm finding the title, and I'm finding the link. And if you look through the scrape Netflix, I find quite a lot of other things there and put them into an array. But this can start to give you an idea of these explicit weights and why you might want to use them and why they're tremendously powerful in terms of scraping things with Selenium. So you will definitely dive into expected conditions. So this has plethora of options for you to determine what element behavior you're expecting. There's an is highlighted, there's a is clickable, there's a is visible, all of those types of things. A lot of them are really straightforward, and you can look up within the class documentation and within the Selenium documentation kind of more details about these depending on what you might need via your script. So there's some other functions that Selenium allows us to have. So if we have anybody here who's a whiz at JavaScript, and this is not jQuery or Node, this is true JavaScript, you can execute scripts in it. You can save a screenshot. This is great for if you're using Selenium for your testing in particular, because if you get an accept when you're expecting no exception to be thrown, you can have it take a screenshot and save it to your test directory or things like that of failed tests. What was happening when I thought I should have been able to highlight and select this element. It's also great if you just like taking screenshots of things. You can switch to an alert. This is going to handle pop-ups. So if you have sites with really annoying pop-ups, you can dismiss alerts using this. And it also has forward and back behavior. So this is great if something doesn't have really great navigation or it doesn't have good pagination or other things like that. You can kind of utilize this to flip back and forth and determine where you are. Okay. So I hope everybody has Selenium installed. If not, please look on your neighbor. Can you search Google for Selenium? And I'll get you started on this. Remember, we have Start Selenium. So we can run Start Selenium. Hopefully you have Firefox installed. I think that's what it uses by default. So here we have our browser, right? So browser.getgoogle.com. And my first question is, can you search Google for Selenium? So I got you to the page. See if maybe you can. Okay, so I'm asking, can you search Google for Selenium? Can you then return a list of the top 5 search results? Can you print out a list of the text of the top 5 search results? Can you click on the first search result you receive? You might also want your keys, in case you want your keys. It's a little hint, maybe, if you're getting stuck. I'm giving little hints. Oh. Great. Well, with my teeny tiny little screen. Teeny tiny. Yeah, yeah. This? This. Won't work on my screen right now, and I will not bore everyone with action chains, because hopefully your browser is not running on a resolution. Maybe try browser.maximize first. Let me. Keys are just keyboards. But yes, you can send keys with the search parameters. Yes, but you can send a key to an element. Yeah. Okay, if a lot of people are getting this, let me. I'm sorry, I have to remember the exact import logic. So you want to then import the action chains, and then you can. I don't have it in my head. Hopefully something like that will help. Oh. Oh, why are you not working properly? The first input might be the wrong one. Mine is also misbehaving. I had this working earlier today. So Might not be. You might, probably not. I mean, the weight is inherent in the fact that we're not scripting, right? It's not running the code. But maybe I can just... Oh, well, that would make sense. Why? Okay, so it's probably not the first one. Okay, so we can start to see. Sorry, it wasn't the first one. It was the second one. So this is where we can start to play around. This should get you a little bit further along. Oh, sorry. Who was able to successfully search Google for selenium? So you should have something like this. Let me, oh, well, now it has changed on me. So you were able to input something like this, right? Maybe you also were able to get into a keys, right? So what I found was that first input, unlike when this was working in America, Google.ca homepage is slightly different in its formatting, or at least in that Google page that it loaded for me at that time. So as the second input, I was able to send keys Selenium that started doing my autocomplete, right? Which then changed the structure of the page with JavaScript. At that point in time, then I can I might be able to do this. And I can start to see these might be P's. And then I might be able to iterate through these as well. So it kind of depends on how the page is structured. This is when you'd start to want to get into the inspect element, right? At that point in time, I can start to look through the links, right? And obviously, A is a little bit too indiscriminate. But if I were to find the CS, you know, I could do the CSS select. And maybe it's a P and then an A. So it's going to start to, these look like at the bottom, the suggestions. So I can start to find the different parts of the page. And then what I could do, is I could start to look up Selenium foods, right? That's probably not what I'm looking for. But you can start to see how you can interact with the page. I don't want to spend too much more time on Selenium. It is indeed one of the very complex things, but it also has a lot of really nice things within it. We really only have 5 minutes left. I'm going to briefly, without a lot of questions, go over the intro to CSV parsing and XLSX parsing. I also want to just put it out there that I thank you very much for sticking with me, and I think you guys did an excellent job. I hope that this is a good first intro to web scraping, that you move on to greatly surpass my scraping abilities. And there will be feedback forms sent for this. I will be hopefully teaching this. I am moving to Berlin. I will hopefully be teaching this class in Berlin upon my arrival at a PyLadies meetup. So please, I appreciate all of the feedback. Give me open and honest feedback. I promise, you know, I'll be in Berlin. I can't come find you. So let's really quickly do a whirlwind introduction. Again, if you have Selenium, XPath, LXML, or BeautifulSoup questions, I am almost always online and almost always available. Please reach out to me, and please fork my repo and do all sorts of fun things with it, and ping me back and show all of the fun scrapers that you've built. CSV for Python is really, really easy to scrape. We have a built-in CSV module. It has a class called dictReader. What dictReader does is, let's say you have a CSV that has a row of titles and then rows of data, which most of them come with. What it's going to do is it's going to create a dictionary with the titles and the data for each row. So what it's going to be able to allow you to do is, I have a CSV, and this CSV is in there. And I'm a big fan of baseball, and I follow the Pirates, which is the Pittsburgh team. And what I'm going to do is I'm going through each. I am using the datetime module to get the start day. That's, you know, the start and end day, thankfully, are the same. Then I'm seeing if PNC Park, which is the name of the Pittsburgh home stadium, is in the location and it's a weekend, then print out home weekend game with the row, passing it the string of the subject, right, which is the game that they are playing, as well as the day. This is fun for me because me and my dad always try to go back to Pittsburgh. He's from Pittsburgh, and we try to catch a home Buccos game while we're there. So this is a great little, really easy to build parser. Again, this is all in the standard lib. So if you need to use a separate delimiter, so let's say your CSV, instead of being comma separated, which inherently really doesn't make it a CSV, but let's say it uses tabs, you can pass the delimiter equals, right? If you don't have any headers for the CSV, if whoever made it only gives a CSV of the data without any headings, you can use the simple CSV reader rather than the dictReader to navigate each row. So it's pretty easy. For XLSX, there are a lot of different modules. I believe that I recommended using XLRD. XLRD, I find, is a lot easier at parsing really large XLSX. So there was recently a study on Crunchbase about a tech bubble, and it was about how many companies that had initial funding are now running out of funds, and it kind of did a study of the past 16 months or so. And obviously, I was curious. And what they did is they released an XLSX of it. Now, an XLSX is not a CSV, right? It comes with a lot of different tabs, a lot of different pages. A lot of times, because it's Excel, it has funny little functions and formulas running. It has macros, maybe. And so you're going to not be able to use any of the standard lib. XLRD, I find, gives it quite a lot of RAM so that it doesn't just whir and kill your computer, which happens with numerous of the other ones. So I'm opening the workbook. Again, this is in that same repo, so feel free to play around with it. I'm finding the name companies. And, you know, I come from a news background, so I said, you know, why don't I find out what news companies got funded that are now running out of funding? So I compiled. You can see here what I'm doing is I am finding the number of rows and I am ranging it, right, which is giving me 0 to the n number of rows, and I'm making myself my own list comprehension to iterate over, right? I could have put this all in these, but for me, this was a little more clear of what I was trying to do. So this is grabbing, again, all of the rows of that sheet. Then I'm going for R in rows. If R3, which is the third input value, is news, right, which I found that column was where they tagged the category, then I'm using this funny function XL date as tuple, which is going to unpack. What you'll find is that Excel uses floats to represent dates from a certain moment in time. Always useful. Thank you, Microsoft. And but luckily, XLRD has this XL date as a tuple. What I can do is I can unpack the first little bits. That's going to give me the date time. And then I say, hey, by the way, this news company, the name, from the city, raised the amount of money with the last funding at this time, right? And again, feel free to play around with these scripts. They're all available. When possible, you want to convert to CSVs. They're more standardized, they're more easy to use. I put in a little code in there that is widely passed around that has all of the credits to the original developer in it and is called XLSX to CSV. I highly recommend using that if you just need this first page or a simple page, but otherwise you're going to play around with XLRD, hopefully. It has a lot of ways to investigate macros and formulas in the name class, so if this is something that you often interact with, it's tremendously powerful. If you don't often interact with XLSX, at least it's nice to have it in your back pocket. So JSON is native to Python. It's a Python dictionary. I gave you guys a quick example where you can go to freegeoip.net/JSON. It's going to load where it thinks you're at based on your IP. So as you can see, it's really simple. JSON.loads is going to load directly from your source string. And it's just really easy to use. Most everybody here has used JSON before. I put it kind of at the end because I'd like everybody to get an introduction to it, but it's very native in Python, and most of the libraries that you touch, whether it's Tweepy or anything to scrape Twitter or Facebook or anything to scrape Facebook, is just doing these simple gets in the background. Again, this is available in the repo, and have fun playing around with it. So, as I said, if you're interacting with an API like Twitter or Facebook or any of the Google APIs, there's a lot of amazing helper libraries out there. There's ones for Facebook that build all the wrappers for you. There's ones for Twitter that build all the wrappers for you. There's ones for Google APIs. There's a Google Places Python wrapper. There's a whole bunch of these. So I strongly recommend that you don't reinvent the wheel and that you use these. You're going to learn a lot even just from working around with these. And if you start to look through the guts of some of the libraries, which is how I learned a lot of the XPath that I first started investigating, it's because it's happening underneath the covers in a lot of these scraping libraries. So I hope that this tutorial was informative and clear. Again, I'll be around. I'll be hanging out all PyCon. I'm giving a talk tomorrow comparing speeds of scraping libraries. You're welcome to come. You can message me on any channel if you run into issues. Remember, most of programming is banging your head against a wall and not giving up, or that's been my experience. So please don't give up. You know, if you have scraper questions or you want scraper advice, I'm always just an internet ping away. So again, those are nice ways to reach me, and thank you so much. You've been a great class. I hope all of you build many, many scrapers. I'll be putting these slides up, and I'll post them to the class link, the tutorials page that hopefully I've been annoying you all with emails from, as well as to my own Twitter feed so that you can utilize them at a later date. And thank you so much for your patience. Yes, they are. So I'll just make them public. Yeah, so then it's available.